Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, especially to our literal Mrs. Deltawati Isti Ratna Ningtyas SPD MPD. My name is Nurhayati bin Nani S. Yunus with student ID A241240009 from class C. Today, I would like to present my work on the topic of electric fields. Okay, let's go in learning content. Number 1, acceleration and repulsion. 2, the concept of an electric field. 3, electric field stranger. 4, force on a checkers. Okay, let's go in number 1, acceleration and repulsion. First, let's talk about interaction and repulsion related to static electricity. Static electricity has many useful applications like in photocopying or air cleaning, but it can also be a nuisance like the small shock we sometimes feel. Objects are usually electrically neutral, but they can become charged when rubbed against another material. There are two types of charges, positive and negative. Opposite charges attract each other, while like charges repel. Also, a charged object can attract a natural one, a phenomenon called electrostatic induction. This is explained by the microscopic structure of matter. Matter is made up of proton, neutron, and electron. Neutral objects have an equal number of proton and electron when the materials are rubbed together. Friction causes electrons to transfer from one to the other. Gaining electron makes an object negative, while losing them makes it positive. Only electron move proton are tactile bound in the nucleus, and electron move freely in conductor or weakly in insulators. Number 2, the content of an electric field. Next, we have the content of an electric field. A charged object experiences a force in an electric field. What is a flash of force? This concept may seem abstract, but is similar to magnetic fields around magnet of or gravitational fields on Earth. We have three main types of force fields: electric fields, which exist on charged objects; magnetic fields, which act on magnets and moving currents; and gravitational fields, which acts on masses. Electric and magnetic fields are closely linked together, forming the electromagnetic force. We represent electric fields as field lines. These lines show the direction of the fields with arrows pointing from positive to negative, and each ring which is indicated by how close or far apart the lines are. There are three case spaces of electric fields: uniform, where the stranger and direction are the same everywhere, like between oppositely charged parallel plates; radial, which spread outwards like around a point charger or a charger sphere; and the field between a charger sphere and a charger plate. Number 3, electric field strength. Now, let's move on to the electric field strength. It is defined as the force per unit charge acting on a stationary positive charge at a point. To determine it, we imagine planting a small positive test charge in the fields and measuring the force it feels. The unit we ask is Newton per coulomb. For a uniform field between two parallel charged plates, The standard depends on two factors. The voltage between the plates higher voltage means a stronger field and the distance between them greater. Separation means a weaker field. This gives us another in for electric field Sanger volt per meter, which is equivalent to Newton per coulomb. Electric field Sanger is a vector quantity, meaning it has both magnitude and direction. Its direction is opposite to the force it exerts on a negative charge. Number 4. Force on a charger finally. Let's discuss the force on a charger to find the force and on a charger in a uniform field. We combine the general definition of field strength with the formula for uniform field strength. For an electron which has a negative charge, the for calculation is adjusted accordingly. This force is important in situations like when a beam of electron enters the space between charge parallel plates. Since electrons are negative, they are attracted to the positive plate and repelled by the negative one. Expression on the word force: if the electron is stationary, it will accelerate stronger down, but if it's moving horizontally, its horizontal speed stays constant while it accelerates downward, following a curved parabolic path. This is similar to projectile motion in Earth's gravitational field, so the effects of gravity on the electron here is negligible. The force on the electron is uniform across the plates and always acts in the same direction. That brings us to the end of my presentation. Thank you very much for your attention. If you have any question, I will be happy to answer them. Wabillahi taufiq walhidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.